So what we will be doing today is graphing a rational function. Now, a rational function, it's basically a function that has an x in the denominator. We need to start by factorizing. This is in order to get any holes or gaps in the graph. So, when we start factorizing, the result is x, which is the common factor, times x squared minus x minus 2. That's for the numerator. Now for the denominator, we have a difference of squares, which will give us the result of x minus 2 times x plus 2. You can see that the numerator can be factorized even more because it's a perfect trinomial square. So the result will be x minus 2 times x plus 1. At this point, we have our factorizing part completed. What we then need to do is to start finding the holes in the graph. Now, holes can be defined as points of discontinuities in the function, and we can get them by simplifying the equation. Now, we have x minus 2 repeated, so we can cross off x minus 2. This will give us our x coordinate of the hole, which by setting it equal to 0, we can find that x equals 2. So our first point in the discontinuity will be 2. Now our next step is to find the y point. Now in order to do this, we need to get our simplified equation and then evaluate the function in the x point of the hole, which in this case is positive 2. Our result here will be 2 times parenthesis 2 plus 1 over 2 plus 2. Our next step will be applying the order of operations in order to solve this equation. So here will be a result of 6 over 4, which we can simplify in 3 halves. Now that's our y point in our gap, and we have found in this case all the gaps or all the discontinuities in the rational function. What we need to do next in order to graph is find the asymptotes. Now, what are asymptotes? Asymptotes are lines, imaginary lines in the graph where the graphed function will never cross. They will get very, very close to it, but they will never touch it. We need to find first the vertical asymptote. In order to find the vertical asymptote, we need to set the denominator equal to 0. Once we did that, we get to the result of x equals minus 2. Now that is our vertical asymptote. Our next step is to find the horizontal asymptote. Now that is a little bit trickier. In order to find it, we must remember 3 simple rules. If the leading coefficient of your numerator is smaller than the leading coefficient of your denominator, your asymptote is at 0. If they're equal, you should divide the denominator of the leading coefficients. However, if the leading coefficient of the numerator is bigger than the leading coefficient of the denominator, you have no horizontal asymptote. At this point, we can see that the leading coefficient of our numerator is bigger than the leading coefficient of our denominator, which gives us the result of no horizontal asymptotes. However, since we have no horizontal asymptote, that means we have a slant asymptote, which is an imaginary line that would never be crossed, only this time it's a diagonal line. We can do this by dividing the numerator over the denominator, either using long division or synthetic division. We get to the result of this length being x minus 1. We're almost done. What we're missing is the x and the y intercepts. This is the last step before we can graph the equation. We can do this by substituting the value of a variable, say x or y, to 0. For example, in order to get the x-intercept, we must substitute all the values of y to 0 and vice versa. In order to get the y-intercept, we must substitute all x's to 0. Getting the y-intercept is harder than getting the x-intercept. In order to get the y-intercept, we must find numbers that, when substituted for the values on the numerator, will give us 0, which in this case are 0 and minus 1. Now, in order to get the y-intercept, we must substitute every x in the equation to 0. Per se, in the denominator, we will have 0 plus 2. And when solving, we get that our y-intercept is 0, 0. Those are the coordinates for the y-intercept. Once we do this, we're ready to graph. And the first thing we do before graphing is draw our asymptotes. Now, we said that our vertical asymptote was in minus 2, and that we had no horizontal asymptote, and that our slant asymptote was in x minus 1. Now, we have a hole, but the hole simply does not matter in graphing. If you have a hole, you just keep on drawing. The next thing we should do is find our x and y intercepts, since they will be enormous data in order to graph. Our next step is to evaluate 2 points in each side of the graph, since they will help us in further graphing. In this case, by evaluating over minus 3, we get that our answer is minus 6. So, 1 point of our graph is minus 3, minus 6. We keep following this process until we have successfully located 2 points on each side of the graph. Now that we found our points, it's time to graph the equation. Now remember that if you're graphing manually, the graph doesn't have to be perfect. You just have to respect every signal that you have been drawing. The only thing that we're missing is the domain and range of the function. Since our function comes from minus infinity and goes to minus infinity, both in the x-axis and the y-axis, we only have to skip the asymptotes in order to get the domain and the range.